Hi everyone, in this video we'll discuss a complete beginner's path to learning machine learning in AI in year 2025. We'll discuss how to get started, courses you should do, books you should read, tools you should get familiar with, literature you should be on top of, and many other finer tips on how to position yourself for a career in machine learning or AI. So let's roll. Alrighty, first thing we need to understand is that to gain expertise in AI, we need to be great at multiple disciplines. As of 2025, when we are recording this video, building products and services which are AI first needs expertise in three major streams: computer software, math, and computing hardware. Let me break this down for you and explain why these three pillars are absolutely essential for your AI journey. Let's start with computer software. Think of it as the language you use to communicate with machines. In AI, you're not just writing basic programs, you're crafting complex systems that can learn and adapt. You will need to master programming languages, particularly Python and some corresponding Pythonic languages, understand software architecture, and know how to build scalable applications. Without solid software skills, even the most brilliant AI algorithms and AI concepts will remain just theories on paper. Now, mathematics. This is your AI foundation. When people say AI is just if-else statements, they couldn't be more wrong. Behind every AI model, there's sophisticated math at work. You will need linear algebra to understand how neural networks process information, calculus to optimize your models, and statistics to make sense of your data. Don't worry if you're not a math genius yet. What matters is understanding these concepts well and applying them properly. Finally, there is computing hardware. Now, this might be a surprise to lots of you folks, but hardware knowledge is becoming increasingly crucial. That, in most cases, is the differentiating factor. Understanding how your code actually runs on GPUs, how memory works, and how to optimize for different hardware architecture can be the difference between 90% and the top 10 percentile. Now, these are three major streams, as I mentioned. Now, let's see how we can master them. Alrighty, now that we understood the disciplines that we need to master, I'll start off with the recommendations on the roadmap that I suggest. And this roadmap is particularly tailored to people who are just starting off in the space of technology and want to straight away jump into the AI space, but it's probably also relevant for people who are thinking of making a switch. Maybe they're a database administrator, maybe they're a data analyst, and they want to learn AI better. First thing first, let me tell you how I am thinking of this roadmap. Whatever you read on the slide, please read it from left to right. These are like step 1, step 2, step 3, and then we go from right to left. Okay, I will explain as I talk about it. So first thing first, as I mentioned, everyone needs to be at least decently okay with Python. Okay, Python is the language on which most of the AI models are being experimented on, built on. Particularly PyTorch. Okay, PyTorch is something that was developed within Meta/Facebook a long time ago, and they open sourced it. But that's the computing language of choice for building and experimenting with AI. So you need to learn Python. Okay. Second, basics of linear algebra. Linear algebra, particularly that we learned in like high school, should be sufficient, but we need to get a decent enough grasp on it and understand the basics, few concepts, particularly chain rule and some others that we really need to master. I'll talk about some of the resources to do that as we move forward. Third, deep learning fundamentals. Deep learning is what is the whole of the AI is around. Okay, you need to master deep learning fundamentals, understand how neural networks are built, what is back propagation, and so on and so forth. I'll also talk about resources around it. And last three are something that I suggest to top off on all these three basic knowledges. First, stay updated on the innovation curve. I will mention how I do it, maybe give some workflows to always stay updated, read papers, read books. But how to do that, how to choose them, I will suggest some pathways around it. Second, system software engineering. We need to get really good at understanding systems, understanding how, if you're using GPUs, which GPUs to use, understanding how to think of what computing configuration when you're building AI models. And I'll also give some resources around how to think around it, some mind maps, how to do that. And finally, build and share your projects. This I will suggest is probably the most important part of your journey. Rather than being students for life, as soon as you start learning something, always try to build stuff and share it with people, get feedback from people. Please do that. I will reckon it's probably the most important part of your journey. Alrighty. So first step is we should learn Python. This slide is for those who have no background in Python, and how they can get started. Again, Python, as I mentioned before, is the language of AI. Most of the experimentation, most of the model build, most of the work happens in Python or Pythonic languages. So you need to have a good base of Python. If I will suggest a book called as Fluent Python, start with reading that book. A really great book. It walks you through the basics and fundamentals of Python. It has really some really good exercise. I will highly suggest doing those exercise. So once you are done reading that book, I would say first of all read that book, okay, before doing anything else. Step 2 is practice coding using a coding assistant, Copilot or Cursor. We're in 2025. No one codes using a simple basic code editor. Everyone uses a coding assistant. So step 1 to step 2 should be fast. It should give you an intuitive understanding of how to write code using Python. Step 3, build a simple API. This is a project which basically tries to make the learnings more concrete that you had in step 1 and step 2. Build a simple API. The API should have user documentation, unit tests, a user walkthrough video. Those of you who are from a different background don't understand what an API is. API is application programming interface. You can literally have an interface for anything. You could literally have an interface where if you write a code and run it, it gives you news of the day or anything per se. Look it up, build that. This thing, step 1, step 2, step 3, reading a book, practicing coding using coding assistant, and step 3, building a simple API which has a documentation and unit test, gives you a overall understanding and learning of Python, but also gives you some flavor of how to do some great software engineering. Alrighty, now we come to great and interesting part. We need to understand the fundamentals of deep learning. AI in its current form is essentially deep learning. Deep learning is what has revolutionized and made artificial intelligence what it is right now. So we need to understand its fundamentals, and there is no better way of doing it than going through a course called as Fast AI. Okay, it has mainly 2 parts. Part 1 is always people who are beginners, and part 2 basically builds on top of it. All videos are free, all texts are free. Jeremy Howard is an excellent teacher. You will be introduced to some great resources while you're doing it. Please do this course diligently. And one of the things that Jeremy also mentions in the course, I will also highly suggest. Don't just go through the course, go through each of the videos, think of a use case, try to code it up, because you would have learned some amount of Python already before you start this course. So build stuff while you're doing it, and you should be really good in deep learning while you end this thing. I will probably say the most important step, or probably the most important part of your learning journey, is this. This is something that I want everyone to understand. Applied AI, as of today, is a discipline of software engineering. Okay, out of all the 3 components that I mentioned before, understanding math, okay, understanding computer science, and understanding hardware. If there is one field that I need to pick, and I will say you should be really good at, it's probably system or software engineering. Okay, because applied AI as of today is a field which needs to optimize software engineering to its core. So, in spite of whichever background you might be coming from, I will suggest try to become a good software engineer. Me, I'm not a software engineer, but over a period of time, I've picked up lots of skills, again, due to me wanting to be a better deep learning engineer and wanting to do other stuff. I've learned lots of stuff, and anyone can do that. So the way I will suggest everyone, and it might sound a bit unintuitive, is learn to develop a web app. Okay, learning to develop a web app gives you the skills or gives you the intuitions that you might need to understand how software engineering basically works. The course that I suggest for this is Howard X CS50's web programming with Python and JavaScript. Great course, teaches you all the fundamental concepts that you need to develop a web app, and even probably a mobile app. You can kind of poke through it and pick out the courses and do it. All the concepts of backend, front end, when do you need a middleware, security. So all the basic fundamentals in just 6 to 9 hours per week, you should be really great at. Though when you do it, you will think, okay, how does it help me become a better AI engineer? the fundamental problem that lots of data scientists or people coming from math backgrounds basically face is they're not able to implement or think through the software engineering concepts. Concepts like flash attention, how to think of KV cache, and all these concepts. These are all majorly software engineering concepts. So become a better software engineer. Second thing that I will probably suggest you is learn more about software architecture, CI/CD pipeline, caches. How do we make your software pipeline more efficient? There are heaps of big books out there. Pick any, go for it, and then find different folks. The biggest thing that I will suggest you is you have to become deeply invested in the art and science of software engineering to become a great AI developer or someone who works in the AI space. Alrighty, so the next thing that I will suggest everyone to do is keep a tab on what's happening in the hardware space. This is something that's probably of paramount importance, and I see lots of engineers, lots of people who are heavily invested in looking at their charts, they're looking at how efficient their code is, and they forget that at the end of it, all the code, all the software, all the algorithms essentially run on hardwares. And there, if you ask me, probably there are a number of times in like last 1.5 years where I've seen people doing really good things, really smart things, but their hardwares are not optimized. They don't understand how GPUs work. They don't understand how memory caches work. So please try and keep a tab on the hardware. As you see here, this is a small chart that I picked up, and it's not updated, it's still 2022, but it essentially says that the flops per dollar is coming down by X every 2 years. Okay, so computing speed is becoming much better. Although we thought that we would be hitting Moore's law higher limit really fast, but innovation is keeping us going. The reason behind why I want everyone to deeply understand hardware, or if not deeply, at least at a high level understand the basic concept of hardware, right? That where does all the data live? Although maybe all the data lives on an SSD, or probably it lives on a spinning disk. Then how does the memory work? How does the GPU function compared to a CPU function? When you're trying to optimize something, when does having a CPU focused task makes more sense compared to a GPU? How do you know if your hardware is working properly or not? Just basics, right? I want everyone to understand that having this basics at hand will make you an extraordinary AI engineer, because you will be able to use the same resources that probably someone else is doing, and will be able to do a better job. So yeah, invest time, invest resources. Lots of books out there, lots of videos on YouTube to understand better how GPUs, CPUs, and any of the computer hardware function. I will see if I can find some more links around some books and stuff that I can recommend, and I will add them to the description. Ready now? Once you have learned everything, not everything, but got the basics right, or building stuff, one thing to understand is AI research and AI as a field is growing at a speed that is breathtaking. Right, 10 years of work is happening in 6 months. The amount of progress and growth that I've seen in like last 1.5 years since I've got deeply invested in large language models and AI research and everything is something that I've not seen across like 12 years of my career. So what I want to convey is things are going to change really fast. So you need to keep tab on the innovation curve. How do you do that? You have to read good research papers. Okay, and how do you find good research papers? There are lots of resources, but one of the ways I do it is I try to subscribe to great newsletters, follow great people on Twitter /X, LinkedIn and everything, so that you get lots of references around things that people are reading. And yeah, just mix and match. But focus area is I will suggest everyone to at least try and read between 1 to 5 good papers from good research institutions. There are lots of them, like there are things come out of OpenAI all the time, Anthropic all the time, DeepMind all the time, and also some great research papers like things that come out of Tencent Labs. So just start reading research papers, right? It will make you a better engineer, be able to think better. When you're trying to solve a problem, try and find research papers around it. And that's how you develop the research side of your brain. So as I mentioned here, some good research papers. Hugging Face has a good newsletter, where they send out good papers of the day, which are kind of community voted. Please subscribe to that. Subscribe to great newsletters, Andrew Neck, Jack Clark, great newsletters, really help you understand lots of stuff. Follow and learn from great experts. If you don't know whom to follow, go to my Twitter with Shub777 and just see whom I follow. I normally, my Twitter is almost dead in terms of like what I tweet, but I use it to keep tab on what people are talking about. So you will find a great list there. Final point is that how do you also flex your brain cells around collaborative learning? The best way to do that is volunteer to speak or contribute at local AI meetups. Okay, you don't need to be an expert to do it. Pick a small topic while you're learning anything. Linear, it could be linear algebra, software engineering, software architecture. Pick that topic and go and give a beginner-friendly talk. One thing that I learned from Jeremy Howard from FastAI a long time ago is he always said, always write stuff or talk about stuff and talk to someone who is in a journey just to probably step back from where you are. I think, and just convey that whatever you have learned to that person. And one thing that I've learned, and one of the reasons why I do these videos, is it helps you a better student also when you're trying to teach someone a concept. So yeah, please go ahead and do that. Great way to make some great friends. Since I started doing it, it has been probably a really, really great experience for me. Final thing, build and share. Okay. All the things that we discussed so far in the video don't matter if you don't start building. So I would suggest start building as soon as you can. Literally imagine any particular problem that you are facing. Okay, try it. It won't be perfect, right? But you will start developing scar tissues, learn stuff, and those learnings will stay with you for your entire life. So start building stuff. It could be anything. It could be, if you love books, build a small recommendation engine around books, or a chatbot around books that recommends great books to a person and then allows them to add it to a list, or give a Goodreads API to do stuff essentially. Or if you're someone who needs a small note-taking app, but you think that current note-taking apps are not that good and you want it to be more conversational, you can build it easily. Yeah, right? So just start building stuff and share it. Good thing over the life is we have so many resources to share stuff. There's Reddit, there's LinkedIn, there's X, Threads, and they're empty in our social networks. And start sharing with stuff and see what community feedback you get, and just build and enjoy your time. But that's it from me. These are like few of the tips that I had for everyone. If you're trying to get started as an AI engineer in the AI space, don't let anyone tell you that you can't do it. Don't need a PhD. You just need good diligence. Really need to dig deep and learn more about stuff. And yeah, that's about it. Please write down in the comments if there's something that you suggest I have missed, or something you will probably like to learn more about, and I will try and cover them in future videos. Thank you.